Okay, here's warm-up number 15. We're going to identify some angle pairs first up. I've got two lines and a transversal. Transversal is just a line that intersects two other lines. So this would be a transversal, okay? All right, so let's see. Angles 1 and 6. So if I look at 1 and 6, they're both at that left intersection, right? And they're on opposite sides of the intersection. So this is going to be, these are vertical angles. 2 and 5 would be vertical angles, so would 1 and 6. 3 and 8 would be vertical angles, so would 4 and 7. So 1 and 6 are going to be vertical angles. Okay. Angles 4 and 5, so that's these two, okay? So these are on different sides of the transversal, okay? If we look at these two lines, I call these the tracks. Sometimes these are going to be parallel and sometimes they're not. Here it doesn't say if they're parallel or not. But these are our tracks, okay? And if I'm looking at angles 4 and 5, they're on the outside of these tracks. So they're on the exterior of the tracks. Now they're on different sides of the transversal outside the tracks. Different sides that I'm going to call alternate to represent they're on different sides of that transversal. And then they're on the exterior of these two tracks. So alternate exterior angles. Okay, just going to silence my phone because it just beeped. All right, so next up, 6 and 7. So 6 and 7 are on the inside of these tracks. So these are going to be interior angles, okay? They're on the same side of the transversal. I kind of like to call them same side interior angles, but our book is going to call them consecutive interior angles. So they're interior angles that are next to each other in a way. Consecutive means kind of next to. So these are going to be consecutive interior angles. Okay, angles 2 and 7, these are on the inside of the track, so they're interior angles. They're on different sides of the transversal, so they're alternate interior angles. Okay, and lastly 5 and 7. So, hey, 5's on the outside of the tracks, but 7's on the inside. So I can't call them interior or exterior angles because I've got one of each, okay? But the way that I can think about this, if you look at the left intersection here, 5 is in the bottom left of its intersection, right? And then angle 7 is in the bottom left position of its intersection. They're in corresponding positions, and that's why these are called corresponding angles. They're both in the bottom left of their respective intersections. Okay. The names of these angle pairs are super important, so spend some time memorizing those if you need to. It's going to be super useful to know those, and it's going to be kind of a disaster later on if you don't know them. Okay, so, all right, moving on to this next problem. So I've got these two angles that are next to each other. They're adjacent. They're stuck together. And together I can see that they form a straight line. Okay? So that is telling me that, hey, those two angles together are going to form a 180-degree angle. They're a linear pair. Together they form a straight line. So that is going to allow me to say, hey, 10x minus 5 plus 4x plus 3 is going to equal 180. Okay, and then I just need to solve this for x, so let's start combining like terms. I can see I've got a 10x and a 4x. I've also got a negative 5 and a positive 3. So those added together would give me 14x, and negative 5 plus 3 would be negative 2. Okay, I'll add 2 to both sides. I'm going to start to try to isolate the x. So I'll start like this. And then the last thing to isolate the x would be divide by 14. Okay, and that's going to come out to exactly 13. So x equals 13. Okay, and so now that I know x, I can find the measure of both of these angles just by substituting the x in. So the measure of KLN, let's see, KLN, that's this angle. KLN is this angle, right? This one here. So it's the 10x minus 5. So 10 times something minus 5. I already figured out what x is, so that something is 13. Okay, so then following PEMDAS, I'm going to multiply before I subtract. So I've got 130 minus 5, and that's going to be 125. And this is the measure of an angle, so I do want to say it's that many degrees. If I'm just solving for x, I can just say what x is, but if I'm finding the measure of an angle, I want to put in degrees. Okay. MLN, that's the other angle, the 4x plus 3. So 4 times something plus 3, and again, that something is 13. So I multiply first. 4 times 13 is 52. And 52 plus 3 is 55, so 55 degrees. There we go. Okay, and that's the end of the warm-up. I will see you next time.